Hello, welcome to SAP HANA tutorial. In this tutorial, I'll be sharing with you the basic concepts of SAP HANA, what is SAP HANA, and later on I'll be showing you the live environment of SAP HANA Studio. So what is SAP HANA? HANA is for High Performance Analytic Appliance. SAP HANA is an in-memory database from SAP to store data and analyze large volumes of non-aggregated data in real time. So basically, due to extreme hardware innovations, that is now main memory is no longer a limited resource, and modern servers can have 2 terabytes of system memory. So this allows complete databases to be held in RAM. So that's why SAP HANA is an in-memory database. The whole database is kept in the RAM. Currently, processors have up to 64 cores, and 128 cores will soon be possible. So, with the increasing number of cores, CPUs are able to process increased data per time interval. So, this shifts the performance bottleneck from disk input output to the data transfer between main memory and CPU cache. And HANA fully leverages the hardware innovations like multi-core CPU, high-capacity RAM availability. So the basic concept is to cache the entire database into fast accessible main memory just close to CPU for faster execution and to avoid disk input output. This storage is still required for permanent persistency because main memory is volatile. So SAP HANA holds the bulk of its data in memory for maximum performance, but it still uses persistent storage to provide a fallback in case of a failure. Then we have massively parallel processing. Again, because of availability of multi-core CPUs, higher CPU execution speeds can be achieved. Now, multiple CPUs call for new parallel algorithms to be used in the databases in order to fully utilize the computing resources available. Then we have hybrid data store. See, common database store tabular data row wise, that is, all data for a record are stored adjacent to each other in the memory. So, row stored tables are linked list of memory pages. So, in case of row oriented storage, it stores a table as a sequence of records, and each of which contains the field of one row. But in case of column oriented storage, it stores all the values of a column in contiguous memory locations. So, a use of column store will help to prevent table scan of unnecessary columns while performing searching and aggregation operations on single column values stored in contiguous memory locations. So, it's hybrid because it supports both row store as well as column and object store as well. Then we have Oltp and Olap databases because it's a hybrid database having both read optimized column store ideally suited for Olap and write optimized row store best for Oltp system relational engines. So both the stores are in the main memory, and using column stores in Oltp requires a balanced approach to insertion and then indexing of column data. SAP HANA database allows the developer to specify whether a table is to be stored column wise or it is to be stored row wise. I'll just show you in SAP HANA Studio. Then we have higher data compression. See, the goal of keeping all the relevant data in main memory can be achieved with less cost if the data compression is used. So, columnar data storage allows highly efficient compression. If a column is sorted, there will normally be several contiguous values placed adjacent to each other in the memory. So, in case of compression methods such as run length encoding, cluster coding, or dictionary coding, these all can be used. So, in column stores, a compression factor of 10 can typically be achieved compared to a traditional row oriented storage system. So, due to higher compression, this again is very fast. So SAP HANA all in all is an in-memory database which provides massively amounts of parallel processing and has got hybrid data store, that is it supports row store as well as column and object oriented as well, and higher compression is there. Now I'll show you the live environment of SAP HANA Studio, wherein we'll be seeing the different perspectives. How do we create the models, the development perspective or the modeler perspective. So let's just open the Eclipse. Okay, so this is SAP HANA Studio. HANA Studio is an Eclipse based integrated development environment, that is IDE, that is used to develop artifacts in a HANA server. It enables technical users to manage the SAP HANA database, to create and manage user authorizations, or to create new or just modify existing models of data. So it's a client tool which can be used to access local or remote HANA systems. We have different perspectives in HANA Studio. So it provides, SAP HANA Studio provides an environment for administration, modeling, and data provisioning. So there are several predefined user interface layouts addressing several application types called perspectives. So in SAP HANA Studio, every HANA system has to have two main subnodes, that is the catalog and the content. We have these over here. This is the catalog and this is the content. These are the main two subnodes which are always there in every HANA system. Then we have the perspectives over here. You can see these are the perspectives opened from here, and we can open some new perspective by clicking over here. These are the different perspectives. Modeler perspective provides provides the views and menu options that enable you to define your analytic model. For example, attribute, analytic, and calculation views of SAP HANA. I'll be showing you how do we create attribute views or analytic views. Then we have the SAP HANA development perspective, wherein it provides the views and menu options that enable you to perform all the tasks relating to application development on SAP HANA Access. For example, to manage application development projects, to display content of application packages, or just to browse the SAP HANA repository. Like that, we have different perspectives. One more perspective we have, that is administrative console perspective. It provides the views that enable you to perform different administrative tasks on SAP HANA instances. We have debug perspective, which provides the views and menu options that help you to test your applications. For example, to view the source code, or to monitor or modify variables and set breakpoints. So that way we have different perspectives based upon different criterias, and based upon your requirement you can just open that perspective from here and it will appear over here. All the windows, all the menu options and views will appear over here for that particular perspective. Then we have these two main subnodes, that is the catalog and the content. The catalog represents SAP HANA's data dictionary, wherein all the data structures, I'll just expand it, all the data structures, tables, data which can be used, these are all specified over here. This is our folder. Here you can see these are because this is for my user ID. Then all the physical tables and the views can be found under this catalog node, and this node contains a list of all the schemas which is used to categorize tables according to the user defined groupings. So this is our schema, and herein I have created I'll just show you the tables which are already there. I have created those tables. Like that, we have these tables, and we can see all the data which is physically stored is contained in this particular schema. There are different schemas over there. Then we have the content node here. The content node represents the design time repository, which holds all the information of data models created with the modeler. Physically, these models are stored in database tables, which are also visible under catalog. Otherwise, this is just the logical representation. This does not contain the data itself. You can see over here, these are the views which are based on the tables over here. So the models are organized in packages. So the content node just provides a different view on the same physical data. Here, if we create different views over here by right clicking, click choose new, and then you can choose any option from here, like attribute view, analytic view, or calculation view. So you can, while creating these views, you can just use these tables which are there in the catalog node. Now let me just show you development perspective. Here you can see again we have the same nodes, but we have three different views. One is the project explorer, another is the repository view, and the third is the navigation view. The project explorer, it shows all the projects of the local file system over here if we choose this. Then we have SAP HANA repository. It shows all the contents on the SAP HANA server. And then we have the navigation view, wherein all the systems which are there are shown. This is shared between the modeler and the development perspective, because you could see when we were working on the SAP HANA modeler perspective, then again it was showing over there. So the navigation view is shared between the modeler as well as development perspective. Now I'll just show you how to create a table, a simple table. There are two ways. One, you can create the table through the user interface, and another through SQL Console from the editor. So first I'll show you how to create a table from SQL Console. Now here we can write the commands. We can write the SQL commands which are there, like to create the table. We have create table command to insert the data into the table. We have insert into table values, this command. So first let me show you how do we create the table. I'll be creating the column type table, right? One is row store, another is column store. I'll be creating the column store table. We have already this product, reseller, and employer. I'll be creating the sales table. So let me just write the command create column table sales, and then the field name, that is product. Let me just see what's the column name over there, and the data type product key. Okay, it's varchar 5, right? So I'll write product. I can write the same name as well, or the I'll just write product ID, and the type would be varchar 5, comma, this is the syntax. Then I'll write the sales amount only. I will just provide the two fields to make it short. Integer. Okay. So now that's the syntax. Now let's just execute it. You can see over here it's successfully executed. You can see how fast it is, right? Now the table is created. Let me just refresh it. Right click over tables and then choose refresh. We should be able to see the table sales. Now let's just enter the values into it. Insert into sales values, and now the values, because that was a varchar, so we have to provide in quotes, and then for integer let's just provide as it is. And now let's just execute it. You can see over here one row is affected. We can type in the different values. We can enter the different values and multiple values by using this command. I'll just show you. We can just put in 100 only. So now you can see we have these two more rows are inserted into this. Now let me just show you the user interface. From here you can see this is how the table is created. You can see the definition over here. You can alter the definition as well, right? If you click on open definition, again this is only opened. So if you want to insert more columns, you can insert, or you can insert more columns using the console. The command is alter table. So by using alter table command, we can alter the design of the table. That is, we can add more columns or remove any column, or we can add the primary key. So this is how we create the table using the SQL console. I'll just show you how to create the table using the interface. Now just new table. There we'll have the option of choosing. You can see over here. Here we need to provide the name of the table. Let's just provide ztest. And from here we can choose whether it's the row store or the column store. We are creating column store. And here you can provide the name of the column. Maybe it's ID. Then we have just name. You can just change the data type, the length or the data type if you want to change. Then age. If you want to keep it integer, you can. So this is how it's created. Now let's just execute it. You can see over here it's executed. If you try to see, then it has executed this command which we put in the SQL console. This command was only appearing over here. This one, create column table. This is the name of the schema which has appeared over there. We can create the from here also. Best way is always to use the name of the schema and then the name of the table, dot name of the table. So here we could write, by default it will put in my schema only. This one, that's the name of my schema. Otherwise it's always because we have multiple schemas, so we should provide the name of the schema always whenever we specify the name of the table. So you can see over here it has executed this statement: create column table, the name of the schema, dot the name of the table, then the name of the column, its data type, null is allowed or not, the name, the next field name, then the data type. So this is how the statement is executed. The SQL statement is executed. Now this is how we create the table and enter data into it. I'll just show you now the SAP HANA modeler perspective, wherein we can create different views. Right now I'll be creating the attribute view. See, there are three views. One is attribute view, then is analytic view, and the third is calculation view. The attribute view is basically created for storing the attributes. Like we have the various properties of the entities, like we have the name, then we have age, then we have salary. Whatever is used to describe an entity is an attribute. So in attribute views, we create we basically put all the attributes in one view, right? So in the language of SAP BW, attribute views are like dimensions, I would say, with just a difference that these are reusable. Other models can reuse this, but in case of BW, the dimension is only local for that cube. So the attribute view is just like a dimension collection of all the attributes. Then we have the analytic views. Analytic views are basically, you can say, it contains the relationship between the attributes and the measures. Measures are basically key figures, right? The fact table which is there in the cube. So analytic views are just like the cubes. If we talk about SAP BW, then we can roughly compare it with info cubes in SAP BW. So all the attributes surround the measures, that is, all the attribute views, all the attributes surround the fact table, and there are aggregation methods on these measures, that is sum, average, minimum, maximum. So we just combine few tables, or we just combine a table and an attribute view in analytic view. So analytic view is created on top of attribute view. Then we can also create the calculation view. I'll just show you. Here is the option of creating the calculation view as well. See, calculation views are the combinations of tables, attribute views, and analytical views. It's just for the complex business requirement only. So whenever there is some situation which is not solvable using the analytic views and attribute views, there we use calculation views. So in that case, calculation views are created by combining two or more analytic views and combining these analytic views with the tables to get answers to the complex questions. So basically there are three information views, right? One is attribute view, then analytic view, and on top of that, calculation. Attribute view is the most basic one. Analytic view is created using the attribute views, and again calculation view is created using the analytic views. So right now I'll just show you how to create a basic attribute view. Here you need to provide the name of your attribute view. So we can just write Z attribute test, right? So we have the option, whatever you select from here, you can create either the attribute view, analytic view, or calculation view. We are creating the attribute view, so we'll be using that. Then we can create these three types: a standard one, a time one, or a derived one. In case of derived one, it is the attribute view is derived from some already created attribute view. It just uses the definition of that view. If we use time, then the time dimensions are also added. That means time columns are also added. It is the data is stored with respect to the time. Then we have the standard attribute view, which is what the normal attribute view. And we have also the option for creating the copy of some view. So if we just use this, we just need to provide the name of the attribute view from which we want to create the copy. So but right now we don't want to create the copy, we just want to create the new one. So just click on finish, and now it will show the window in which there'll be semantic node, and then there will be data foundation. We call it scenario. You can see over here, this is the data foundation, this is the semantic node. When you click on data foundation, here you can add the tables into it. Whatever tables you want to see in the attribute view, you can create it on one or more tables. If you create it on one table, then it's a very simple view wherein all the columns of that table are included in the view, and you can just decide on what's the how you want to see the output, what columns you want to see in the output. But if you are using multiple tables, then you need to join those tables using either of the join, self join, or inner join, or right outer join, or left outer join. And first, let me just show you how do we create the attribute view, how do we put the tables into attribute view. Let me just put the table. So we can just drag and drop the table from here. If I want to put this sales table over here, so I can just drag and drop it over here. Okay, it's just hanged. Yeah. So this is how it's dragged and dropped, and you can see it over here. Now we need to, whatever field we want to show in the output, we just need to select that field. Just select the field and right click on it and add to output. So that way, these are the column in this column folder. You can see now in the output, product ID would be shown. If you want to see sales amount as well, then add to output. Now sales amount would also be shown. This is the calculated columns folder. Here you can create some calculated column as well, like some formulas you want to put, some computation you want to do. You can just create that calculated column, which is local to this attribute view. If you choose new over here, then you'll have the option of creating the calculated column. Right now we don't want to do, we just want to create the basic attribute view. Now we have created the output structure. Now we need to go to the semantics node, and herein we need to provide the key. Right, from here we have these two columns, and on the type column we need to choose the key attribute. Okay, so which should be unique for all the rows. So this is also a mandatory step. So there are two mandatory steps when everything else is optional. First mandatory step is to create the output structure by when we clicked over here and we selected the field and added it to the output. That's the first mandatory step. And the next is to assign a key to create the key attribute. Rest others are not mandatory. You can hide something, or you can create the calculated columns, or from here you can put the filters. You can just put the filters, get the selected values only, not all the values. So like that, rest of all the options are optional. These are not mandatory. Only two options are mandatory, that is to add to the output, because there should be something for the output, right? That's why we are creating the view. And second is to assign the key. So this is how it's created. Now let's just first check it, validate it. You can see over here it's completed successfully. Now let's just save and activate it. So you can see over here it's completed successfully. Our attribute view is created. Let's just see. Yeah, this is our attribute view. Z@test. test. So this is how an attribute view is created. Now on top of this, an analytic view can be created, and then a calculation view can also be created.